So last time we have discussed about the properties of an acid. I'll just share my screen. So in the previous class, we have started with the chapter acid, base, and salt. There we have discussed like all the different kind of the foods have the different type of the taste depending on the texture, depending on the taste of it. So three substances we have categorized them into acid, bases, and salt. Acid word has been derived from the Latin word called as the acidus, which means sour. So the substances which taste sour, they are basically the acidic substance, or they are called as acid. The lemon has citric acid, orange has citric acid, curd has lactic acid, vinegar has acetic acid. Then acids, they are the compound in which a compulsory one element will be what? A hydrogen element will be there. For example, hydrochloric acid, in the hydrochloric acid, hydrogen is there. Then sulfuric acid also, H2SO4, hydrogen is there. So whatever the substances are there in them, what is compulsory? The presence of hydrogen is compulsory. Then some of the acids are naturally occurring, which are present in our food item, like the lemon juice, orange vinegar, and all. Properties of an acid we have started. Sulfuric acid is called as the king of all the acid because it is like it destroys like most of the things if used in a wrong way. Then we have also discussed about the difference between the dilute and the concentrated acid. When we talk about the dilute acid, they will be basically presence of water in the acid. So when we add water in the acid, it becomes dilute. And when we don't add any water in it, it will be concentrated. So high amount of water will be the dilute and the low amount of the water will be the concentrated. Then acidity we have discussed about the acid base. Acid should have the hydrogen in them compulsory, whereas the bases should have the OH minus ion compulsory. Now we'll be starting today few of the reactions. We'll be discussing the reactions and the properties of the acids. So properties of acids. The first thing is acids are sour to taste. So whenever we taste them, they will be sour. The second thing, they turns blue litmus to red. So litmus is a kind of paper. It is of different color. So if we are taking the blue color litmus paper, if we dip it into that acid, what happens? The blue color of that paper will turn into the red color. Then third property of it is acids can corrode metals. Acid can corrode metal like aluminium, and iron due to their corrosive in nature. Now, what does it mean? Like in a very simple example, you might have seen the pillars at your home. Pillars at the home, or maybe might be in the school, or might be any other factories. There, the pillars will be made up of iron. And iron, after some days, if the new iron is there, after some days, it start getting rusting. Do you know what is rust?
Yeah.
Right? So that brown color, the reddish color, brown reddish color will be coming on that surface, right? That is called as rusting. Now, why it happens? It happens because when the aluminum or the iron is it is exposed to air, then what happens? The acids, they will start reacting to it, and then they convert the color of it into the other color. So they will corrode it. That is why the acids, they are called as corrosive materials. Why? Because they will be corroding. Corroding them means they will be destroying the property of it. So Qutub Minar, like Qutub Minar you have. So there you have a long pillar. So that pillar also have the same problem. So corrosive nature of an acid is the property of it. And then you seen in your lab that the acids are stored in the glass container or the plastic container in the school?
One glass container.
Yeah, Anubhav. So they are stored in the glass container. The reason why they are stored in glass container, it is because if we are storing them in the plastic container, what happen? They will be corroded or they will get melt away because acids they are highly inflammable. What happens? They will just burn the plastic bottle or plastic material of it, so which can be harmful. That is why the glass are being used to keep all the variety of the acids. So glass will not have any impact of the acids on it. So due to its corrosive nature, what they will be doing, they will be storing them into the glass container. So that is why acids are stored in glass containers and not in metal container. So that is why they are not storing in metal container, because if they store in the metal container, they will corrode, they will spoil them. So that is why they are stored in the glass container. Now fourth point, acids are soluble in water. Now what do you mean by soluble in water? What is the meaning of soluble?
Ma'am, they mix with the water.
Very good. So they get mixed easily with water. Like for example, if I want to mix hydrochloric acid with water, easily it will get mixed. So any acids, whatever acids we are taking, if we mix the water in it, easily it will become soluble. So that is a property of an acid. Then acid solutions, they conduct electricity. So what do? They help in producing the or flowing of the electricity. You might have seen like some of the acidic materials are being used to produce the electricity. So if the acid is there, then what happen? The charges. Have you ever heard the word charges? The positive charge, the negative charge?
Yes, ma'am.
Very good. So these charges, positive charges and negative charges, are present in the acids. So because of these charges only, the electricity is being, flow from one to the other place. So that this is also the property of an acid, that they conduct the electricity. And the next property is all acids generally contain hydrogen. So what do they have? They have hydrogen. So this point already we have discussed. So whatever acid name we know, whatever acid we know, all the acid, what should they have? They should have the hydrogen element in it. So this is very important property, that if any acid is there, it should have what? It should have the hydrogen. Coming to another very important property is when acids react with metal. So when acid react with metal to form a salt, or I can say they form a salt, and hydrogen gas is released. Hydrogen gas is released. Like, do you know what are the metals in our periodic table? Have you ever heard the word metals or the periodic table?
Yes, ma'am.
Okay. So the metals are present in the periodic table. So any of the metal, if they react with the acid, then what happen? They will form the salt and they form the hydrogen. Now we'll understand this with an example. Like for an example, now I said acid react. Now acid, suppose for example, I am taking the acid hydrochloric acid. Now I said acid react with metal. Now what metal I am taking here? I am taking here Mg. What is Mg?
Ma'am, magnesium.
Very good. So it is magnesium. So I have written hydrochloric acid, which is an acid here. And then I said acid react with the metal. Magnesium is the metal. Now, in the property I have written acids react with metal, they form a salt. So these two together, they will join, and what do they form? They form MgCl2. And what do they release? A gas called as hydrogen gas. Now, what is MgCl2?
Ma'am, magnesium chloride.
Very good. So Mg stands for the magnesium and Cl2 stands for the chloride. And this magnesium chloride is what? It is a salt. And H2 is what? It is the hydrogen gas. Fine. So it's like very, very important property. Whenever the acid reacts with the metal, what do? They form the salt and they release the hydrogen. Now another example we'll see, like if we have HCl, we have a metal called as zinc. So what will be formed now? What these two will form?
Ma'am, zinc chloride.
Very good. So it will be ZnCl2, which is zinc chloride. And this zinc chloride is what? It is a salt. And which gas do they release?
Hydrogen.
Hydrogen gas they release. Clear?
Okay, ma'am.
So any doubt, Varshit and Anubhav?
No, ma'am. No, ma'am.
Okay. Now I'll give you a few metals name, okay? Few metals name I'm giving you. You tell me what is going to be made. So PB. Now we have the PB. Apart from the PB,
Ma'am, it
I'll
is
give.
Latin name.
It is
Ma'am, a Latin name.
Latin name, but what might be, you will be learning. I'll just give a normal name. Wait, this will be a little higher level. It is called as lead actually, but I'll start with a little easier name. Okay. Huh. So, with the name called as Ca. What is Ca?
Ma'am, calcium.
Correct. So, calcium. Now, we have HCl, we have calcium. Now, acid here we have the metal here, calcium. Now, what do they form?
Ma'am, calcium chloride.
CaCl2 plus H2, which is calcium chloride and hydrogen gas. So like this, we have to understand, like whatever, whenever acid reacts with the metal, they form what? They form the salt and they release the hydrogen gas. Now going ahead with the next property, the eighth property, acids react with bases. Now I said acid reacts with bases. In the last property, what they were doing? They were reacting with the metal. Now in this property, they are reacting with the bases to form salt and water. So in when they react with the metal, then that time also what do? They form the salt, but they release the hydrogen gas. But now when acid reacts with the bases, they form the salt, but they releases the water. Like for example, now acid, suppose for example, acid is HCl. Now base I'm taking NaOH. So this is hydrochloric acid. What is NaOH?
Ma'am, is it the sodium hydroxide?
Correct. So it is sodium hydroxide. So this NaOH, sodium hydroxide, or it is also called as caustic soda. I think in the class 6th, you have heard this word caustic soda while doing the experiment for the protein, right? For doing the
Yes.
experiment for the protein, you need the copper sulfate as well as the caustic soda. So caustic soda, other name of caustic soda is sodium hydroxide. So when HCl is now acid here, okay, and then NaOH is what? A base here. And I said, when acid react with the base, what they do, they form a salt. So these both will be joined together and they form NaCl. What is NaCl?
Sodium chloride.
Very good. It is the sodium chloride. And this is also a type of salt. And what do they release? They release the water also. Clear?
Yes, ma'am. Yes, ma'am.
So this NaCl is basically the normal salt. So whatever salt we are using at home, that is the NaCl only. Fine?
Yes, ma'am.
Okay. Now, I'll give you one more example of it. So now we have the HCl plus I'm giving you MgOH. Now what is MgOH? What is Mg?
Magnesium.
Correct. Mg is magnesium. And always keep in mind wherever OH comes, OH means hydroxide. Okay. Like in the previous name, it was NaOH. Na was sodium. And what was OH? Hydroxide. So wherever the word OH comes, it means hydroxide. So magnesium hydroxide. Here HCl is an acid. Then MgOH is what it is? A base. Now both of them, they will join together and form what? Yes, Anubhav and Varshit, both of them, they will join together and form. They form the magnesium chloride. MgCl2 is magnesium chloride. And what do they release? They release the water also. They release the water also. Clear? So this is a salt.
Yes.
This is the water. So whenever the acid reacts with the metal, they form the salt and release hydrogen gas. And whenever the acid reacts with the base, they form the salt but release the water. And this property, when acid reacts with the base to form the salt, this kind of reaction is called as neutralization reaction. So neutralization reaction is a reaction in which acid and bases both reacts with each other to form the salt and water. Clear?
Yes, ma'am.
So I have given you, I think last time I've given you the example of the toothpaste also. I have asked you like what type of acid is there or the base is there in the toothpaste. So always a base will be there in the toothpaste because our mouth has what? Acid. So mouth has, our teeth has acid, the toothpaste has a base. So whenever the acid reacts with the base, the neutralization reaction happens. So this acid will be removed by the toothpaste and hence the neutralization reaction occurs. That is why we clean our teeth. All right.
Yes, ma'am.
Now, a question. What do all acids have in common? Yes, what do they have in common?
No, hydrogen.
Very good. So what they should have? They should have hydrogen. So generally, all the acids contain hydrogen. So this hydrogen, the hydrogen present in the acid, the hydrogen present in acids in such a way that when acid dissolved in water, it gives positively charged hydrogen ions. Now, very simple, I'll explain this. So, we know that hydrogen is common in all the acids. Now, what happens whenever these acids, they will be dissolved in water, or we can say whenever we add water in the acid, what do? They start giving out the H positive ion. This positive ion are called as the hydrogen ion. So as soon as the acids are mixed with the water, they start giving out the positive charge hydrogen ion. Thus, what happens? The acids dissociates. What do you mean by dissociates? Dissociates means break, okay? So when acids dissociates on dissolving in water to produce which type of ion? To produce positive hydrogen ion. So acid when mixes with water, what do? They start releasing the H ions. So dissociate means break down. The acid will break down when dissolving in water, and what do they produce? They produce the H plus ion. For example, now, example, HCl. So we have HCl. Now, as soon as we have mixed this HCl in the water, what happened? This HCl will break down into H plus and Cl minus. So what is this HCl? It is hydrochloric acid. This is hydrogen ion. And the Cl minus is what? A chloride ion. So you can see that when the water is being mixed, the acid start breaking down into the hydrogen ion. Clear?
Yes, ma'am. Ma'am, but you have said that it will be dilute hydrochloric acid then?
If it is the
Ma'am, dilute hydrochloric acid after mixing.
yes, if that is dilute hydrochloric acid also, then we are not bothering about it because everything is what there in the container only. So this reactions when happen, like for example, now I said I have a beaker. In the beaker, what I did, I have added the acid is already there, and I have added the water. Now I said that it will start releasing hydrogen ion, H plus ions. But all these H plus ion, where they will go? They will be in the bottle only. They cannot move anywhere. At the same time, if this acid, hydrochloric acid, along with the water, I am mixing maybe with the zinc. Now what happened? They start connecting together and they make another compound. Clear? If it is in the bottle, all the hydrogen ions will be there only. They will not move anywhere because there is no one to react with. But in the case, if something more is added on along with the water, what they will do, all the negative ions, they will go and attach with the metal and the hydrogen ions will separate out of it. Like this reaction. Clear?
Yes, ma'am.
Okay. Now, I'll play a video.
Acids, Bases and Salts, Part 2. Friends, did you feel the sourness in your mouth when you saw me? I'm very unique. Mix me in water or in food. Lick me or like me, but I'm unique. In the previous video, we all had gathered important information about acids and bases. Remember, the teacher told the children that they should bring turmeric, flowers, onions, and other
So
things
basically here
from
what
home.
they're doing, they're talking about the indicators, right? So indicators, they are substances which are added to give some kind of the other kind of the property. Like if I talk about the turmeric is a kind of indicators which are being added in the vegetables or which they act as an antiseptic also. So they are the different indicators for the different purposes.
So that they could all experiment together, let us see what children have brought from home. So let's go with the kids to their school lab today. I too am curious to know. Come, let us wear a lab coat and become a scientist.
Today I have brought turmeric for the experiment. What have you all brought?
Hey, I also brought turmeric. When I was taking out turmeric yesterday, it fell on this handkerchief. Look what happened. How many ever times I tried to wash with soap, but there is a very stubborn stain. I will show sir and will ask him what is there in turmeric.
I have brought a hibiscus flower. I have a hibiscus plant at home.
The bell rang. Sir will come. Let us go soon.
Very nice. Children have brought different things from home. Looks like there will be a lot of fun in the lab.
Good afternoon, children. I told you about acids and bases yesterday.
Sir, aren't you going to talk about their indicators today?
Yes, as we cannot taste all substances, indicators help us determine the difference between acids and bases.
Oh, there is something called an indicator also. Come, let us see what they are. Sir, I have brought hibiscus flowers. Why did you ask us to get them?
Turmeric, hibiscus flower, purple cabbage are a few of the natural indicators.
Is it? How do indicators help us?
Whether a substance is acidic or basic is determined by these indicators. Indicators are of two types, natural and synthetic. Synthetic indicators are prepared by humans in the lab.
Sir, I am also surprised how these can be indicators.
Not only these, there are many things that can be used as indicators. You will be surprised to know that onions and garlic are also indicators. Concluded that The turmeric strip changed the base to red and there was no reaction in the acidic solution.
Sir, do all the bases turn red when we come in contact with turmeric?
These children have deducted what I did a few years ago. How clever are these children? Yes, and turmeric does not react with acid. That is why turmeric strips did not change color when they came in contact with acid.
Now I came to know why when I washed my handkerchief with soap yesterday, soap made the turmeric stain red.
Oh wow! What a fun experiment it was. Children have really become scientists.
Good observation.
So these are like what the small experiment you can try doing at home. So you might have seen sometime like by chance what happened, the turmeric fall on any piece of cloth. If we try to wash them with the help of the soap, the color of it will start changing into the red.
Children, a commonly used indicator is litmus paper. It is taken from lichen. It is a natural indicator.
Sir, are these red and blue strips litmus paper?
Yes, I have taken 2 bowls and put 2 liquids in them.
Sir, shall I come and put these litmus papers in these bowls and see what will happen?
Come on.
So, when I dipped the red litmus paper in a solution, it had no effect. When I dipped it in the other solution, it turned blue.
What happened to the blue litmus paper?
It has the opposite effect. While I put it in one fluid, it has no effect, and in the other, it turned red.
I wonder what is the secret of blue and red paper? Let's find out.
As I told you earlier, this paper is made of organic material called lichen. When the red litmus is dipped in an acidic solution, it does not show any effect. But when it is dipped in basic solution, it turns blue.
Sir, I have now come to know that when the blue litmus paper is put in basic solution, why it does not show any effect, but in acidic solution, it turns red.
Yes, now all of you have come to know which of these two is acidic solution and which is basic solution.
Yes, sir. Thank you.
By using this method, the great scientist Robert Boyle also discovered acids and bases. And see how these children also solved a big problem by themselves. You should also ask your teachers to conduct these experiments so that you can also get more information about acid and basic substances.
Sir, can you explain this process when both acid and bases are mixed?
I will explain that in tomorrow's class.
Children, we have seen how
So we'll be learning about the indicators in the upcoming class. Like so many indicators are there. So hibiscus, like hibiscus is also called as China rose. So that also act as an indicator. The onions are there, the garlics are there. They also act as an indicator. So we'll be learning about all these in the higher class, in the upcoming classes. All right.